Alright, Caitlin, hopefully this will help you in understanding this question. I thought it'd be easier to make a video with an explanation than just sending the PDF file and having you try to interpret this. Your question was, what volume of a liquid is present if a container's mass is 36.8 grams empty? When a liquid is added to the container, the mass is 68.9 grams. That's the container with the liquid. The density of the liquid is 1.77 grams per centimeter cube. The first thing I want you to recognize is, and I think you did this okay, is the equation for density. Its density is mass over volume, and in this case it's grams over centimeter cube. I don't know if your teacher requires you to do this, but I always have my students rearrange the variable and put the variable that you're looking for all by itself. So you'll notice that the density equation, still mass over volume, excuse me, we want to get the volume all by itself. And we want to get density, in this case, since we know the value for density and we know the units, we want to get it to the other side of the equal sign. One real neat trick in algebra, if you move a variable from one side of the equal sign to the other, if the number is in the numerator, it'll go in the denominator on the opposite side. If it's in the denominator, like the volume is here, it'll go in the numerator on the opposite side. So if you ever move variables from one side of the equal sign to the other, they're going to be in the opposite position, numerator or denominator. So what we're going to do is we're going to actually have the density and the volume variables switch places. So now our equation looks like that, where we have volume over volume is equal to the mass divided by the density. Now, that is huge. If you can do that to all of your equations, I mean, especially once you get into the second semester when you're doing gas laws, and trust me, you'll want to do that to keep you out of trouble, because what happened, based on what the number that I saw that you actually calculated, you left the equation as is. You didn't change the variables around and you just plugged the values in. You got a really bizarre number. Alright, sorry, let's go on. So it looked like you calculated your mass correctly. So you took the mass of the container with the liquid, 68.9, subtracted it from the container's mass and came up with just the mass of the liquid, which in this case is 32.1 grams. Once you've got the mass, now we have two of the three variables and we're ready to go. So again, we have our equations, so we're set up here for the volume is equal to the mass over the density. I plugged in the mass that I just calculated over the density that was given. Now one thing I want you to notice here, and I'm not real sure if many teachers have you do this, but again, it's another step to help keep you out of trouble, is that you'll notice that the grams divided by centimeters cubed. Well, you and I both know that grams over grams is going to cancel out. And then we're going to be left with essentially 1 divided by centimeters cubed. One thing I don't like to have, and I teach my students this, is if you have two dividing lines, you only need one. Just recall that your centimeters cubed here is always going to go on the opposite side of the dividing line as the grams. So in the next step here, you'll notice that I have centimeters cubed on top, which is exactly what we want if we're looking for the volume. I mean, if we're looking for volume, we're looking for the centimeters cubed in this case. Once you've got your units in the correct place, type it in on your calculator, and hopefully you get a right number. Now, if you need to check something real quick, you can always take the mass divided by the volume you just calculated, and hopefully it'll give you the 1.77. I hope this has helped. If you have any more questions, don't hesitate to ask.